Today we are going to be talking about sets of numbers. A set is a collection of items called elements. So the set is the whole thing, and what is inside of it is called an element. A subset is a set whose elements all belong to another set, and we'll be looking at subsets when we look at the real number charts in just a second. An empty set can be shown as a circle with a line through it, is a set containing no elements. So it's exactly what it says. It's an empty set, has nothing in it. All right, here is the real number chart. You are going to want to write this down and save it with your notes. You also want to make sure that you have these letters that are behind each topic because those are going to come in handy later on. I want to talk about natural numbers first. That's the smallest circle here. Natural numbers are just counting numbers. If I asked you to count, you would start at 1. So those are natural numbers. Then the next number set outside of that would be whole numbers, and whole numbers are all of the natural numbers, but we've added 0. And then the next one is integers. Integers are whole numbers and natural numbers, but now we've added the negative numbers. And then rational numbers are all of those below, integers, whole, and natural, but now we're adding the decimals and fractions in. And then over on the right-hand side, we have irrational numbers. Those are numbers that don't terminate, but they don't repeat either. So things like pi goes on forever, but it does not repeat. Square roots of numbers that aren't perfect squares. So if I gave you the square root of 25, that can simplify down to 5, so that would go over in the natural number category. It wouldn't stay over in the irrational numbers just because it has a square root, a radical symbol. And all of these numbers in this chart are real numbers. So everything in the colors is a subset to a real number set. And then underneath of here, if you want to pause the video, these are the words that I just talked about. They're the definitions to the different types of numbers up above, but I just went over them. All right, we're going to consider these numbers, and we have to order them from least to greatest. So when I look at that list of 5 numbers, I see that 2 of them are in decimal form. Well, actually 3, because 0 is considered decimal form as well. So 3 out of the 5 are in decimal form. So I'm going to change everything to decimal so it's easier to compare. So negative 5 halves is the same thing as negative 2.5. So negative 2.5. And then the square root of 2, I can use my calculator for, and I get 1.414. So putting them in order from least to greatest, the negative number, there's only one of them, and that has to be our smallest number. So negative 5/2 is the smallest. So we've used that. Then we have a 0, and then we have 0.6 and 0.5129. So 0.5129 would come before 0.6. And then our last number would be the square root of 2 as our largest number. Then we have to classify each one of these numbers. So the first one we're going to start with is the 0.6 or 6/10. And if I go back up to my chart here, where do I see decimals? I see decimals in the rational number category. And rational numbers is part of real numbers. So I have to write both of them, rational and real. Then moving on, we have square root of 2. If I go back up there, and I know square root of 2 simplifies down to 1.414 and some more decimals after that. So it is not a perfect square, so it definitely fits over in the irrational category side. And irrational numbers is a subset of our real numbers, so we have to write both irrational and real. And then we have 0. So if I go back up to my chart, 0 is in the whole number category, and whole number is also an integer, a rational number, and a real number. So it is you find the lowest category it can fit in, and then you have to write everything above it because it's in all of those as well. So whole, integer, rational, real. And then we have -5/2 or -2.5. And again, fractions, decimals come in under the rational numbers. So rational numbers is also part of real numbers. So this would be rational and real. And then we have 0.5129. Again, that's a decimal, so that would fall with rational numbers. And rational numbers is also real numbers. All right, moving on, a couple more vocab words here. We have roster notation. Roster notation is the elements of a set are listed between braces. So if we have certain numbers, so if I asked you to create a set of the numbers on a number cube or a die, they would be 1, 2, 3, 4, and 5, and 6. So you would list those between these braces here. Notice they're a little squiggly on the side. We have a finite set, which has a definite number of elements, and an infinite set, which has an unlimited number of elements. So a finite, we know, stops. Infinite set can go on forever. So the set of real numbers between 3 and 5, which can be an infinite set, can be represented on a number line or by an inequality. So I have an inequality here, and we have two inequalities put together here. So we have a compound inequality. Our first inequality is right here, where the inequality sign is open towards the x. So that means x is our bigger number, so x is greater than 3. And then we have our second inequality here, which is x is less than 5. So x is greater than 3, but it's also less than 5. And if we were to put this on a number line, we have 3, 4, and 5. We have circles at 3 and at 5. Our inequality symbols are not underlined, so we're not going to fill in those circles, but we're going to shade in between the 3 and the 5 because we're including everything in between there. Next, we're going to talk about interval notation, and that's where these brackets are used to include an endpoint in an interval, and parentheses are used to exclude an endpoint from an interval. So underneath, I have both types here. The parentheses would mean we're not including those, so those would be the inequalities less than or greater than. And then with the brackets, those would be including the 3 and 5, so those would have the line under it for the equal to part of the inequality. If an interval extends forever in either direction, we would use the infinity sign. If it's going towards the positive side, we would use just a positive infinity. If it was going on forever towards the negative numbers, then we're going to put negative infinity because we have no idea when it stops. It goes on forever. So our first example is represent each interval on a number line as an inequality and in interval notation. So numbers less than 3 on a number line. So less than 3 means smaller than 3, so we're going to shade to all the numbers smaller. And less than is not included, so we're going to leave the circle open. Our inequality is going to start with an x and end with our 3. And less than means the 3 is bigger, so the inequality is open towards the 3. And then our interval notation is going to go on forever towards the smaller numbers. So that means I'm going to have to put a negative infinity sign because it goes on forever. to the left, and it stops at 3. So our other number is 3. And we're not including either of those numbers, so we're going to have parentheses. Numbers greater than or equal to -2. So this time I saw the equal to or heard that, so we're going to definitely fill in the circle. At -2, numbers greater than are going to go to the right. Bigger numbers are always to the right. So fill that all in. And then to write our inequality, we're going to start with x and end with -2. We're going to have an underline on the inequality because it's equal to, and x is greater than these numbers. So the inequality wants to open towards the bigger number x. And then for our interval notation, we start at -2 as our smallest number, and we're going on forever towards the right. So that's the infinity sign. It goes on forever. And we're going to use a bracket for -2 because we actually are including the -2, but we're going to put a parenthesis for the infinity sign because it goes on forever and we're not including, there's no end number to include. Then we have numbers between 2 and 4. So number line here, circle at 2 and 4. We're between them, we're not including them, so we're just going to shade right between the two. Our smallest number is 2 and our largest number is 4. We have our x in between. So x has to be larger than 2, so the inequality is going to open towards the x. And then x has to be smaller than 4, so we want less than 4. And then for interval notation, our smallest number is 2 and our largest number is 4, and neither of those are included, so we're using parentheses. Then we have numbers 1 through 3, which is including the 1 through 3. So the only difference is we're going to fill in our circles on our number line and shade between the two numbers. Our inequality, our smallest is 1, our largest is 3, x is in the middle. 1 is the smallest, so x has to be bigger than 1, but include it. And x also has to be smaller than 3, but include it as well. And then for interval notation, we have 1 to 3, and we're including both of those, so we're going to have 2 brackets to show that. For our last two, we're going to use interval notation to represent each set of numbers. So this one is going between 4 and 6. I noticed that the first one is underlined, so it has to be a bracket to include it, but the second inequality is not. So we're not including 6, so we use a parenthesis. Last one here has actually 2 different things graphed on the number line, so we're going to focus on between the -5 and -2 here first. So -5 is our smallest number, -2 is the largest number. Both circles are filled in, so I'm going to use brackets for those because we're including both of those. And then our other one is just greater than 3. So our smallest number would be 3, and our largest number would be infinity because it's going on forever. Notice that the circle is not filled in, so we're not including 3, so that's going to be a parenthesis. And then we don't have an endpoint for infinity, so we can't include it, so it has to be a parenthesis. Now, the numbers that we're talking about here on this one number line can be in either of these spots. So we're going to put an or sign, or between them, because it could be over here between -5 and -2, or it could be over here greater than 3.